Find the directional derivative of the function at point P in the direction of V. The function is x squared times y. The point is negative 5, 5, and the vector is 3I minus 4j. So the formula we need is the gradient of f dotted with a normal vector, or with a unit vector. So we'll do v over the length of v. So first, let's find the gradient of f. So take the partial derivative first with respect to x. So that's going to be 2x times y, because y here is a constant. And then when you take the partial derivative with respect to y, x squared is the constant. So the derivative of that is x squared. And next, let's find out what it is when we plug in negative 5, 5 into the gradient. So it's 2 times negative 5 times 5. And then x squared is just negative 5 quantity squared. That simplifies to negative 50, comma 25. Now the vector v here is not a unit vector, and the quick way to finding the length is to notice it's a 3, 4, 5. Think of it like a 3, 4, 5 right triangle. But if you want to find the length, you just take the square root of all the components squared, and you'll see that it's 5. Okay. So u will be the unit vector. You take vector v divided by its own length. So take vector v divided by 5. So instead of 3, it's 3 over 5. Instead of negative 4, it's negative 4 over 5. Finally, we're going to be taking the dot product. So take the dot product of the gradient of f. And then with the unit vector, I'm just going to write it in this form. So you're going to multiply the x's. Negative 50 times 3/5. That's negative 30. And then 25 times negative 4 over 5. That's going to be negative 20. So the final answer is negative 50. Find the gradient of the function at point P in the direction of v. So we have the function f of x, y, z equals ln of x squared plus 2y squared plus 3z squared. The point is 2, 1, 4. The vector v is negative 3 over 13 I minus 4 over 13 j minus 12 over 13 k. So here we need the gradient of f evaluated at the point, dotted with a unit vector, so v over the length of v. First, let's find out what the gradient of f is. So let's take the partial derivative, first with respect to x. Because f is a natural log, we're always going to do 1 over the inside. And then we're going to multiply by the derivative of the inside. Y and z are constant, so we can ignore those because the derivative is going to be 0. And you just take the derivative of x squared, which is 2x. Now when we take the partial derivative with respect to y, we're still going to have the denominator as what's inside the parentheses. And then take the derivative with respect to y, so that's going to be 4y. And same thing with z. Same denominator. And then take the derivative of the inside with respect to z. That's going to be 6z. Now we want to plug in the point 2, 1, 4 in here. And when we do that, we have 2 over 27, 2 over 27, and 4 over 9. Now we want to find the unit vector of v. So recall that v is negative 3 over 13i minus 4 over 13j minus 12 over 13k. Here, if I square each of the components and I take the square root, I do indeed get 1. So this is already a unit vector. So I'm not going to do anything to it. So all that I have to do is take this vector and do a dot product with the unit vector of v. So that would be negative 3, 13, negative 4 over 13, negative 12 over 13. So you'll be multiplying each component and then adding it at the end. So we get negative 158 over 351 as our final answer. Now we want to find the critical points of the function by completing the square and then verify the results using the partial derivative test. Okay, so we have a function f of xy equals x squared plus y squared plus 2x plus 6y plus 6. Let's group all the x's together, and then let's group all the y's together. And the 6 here, I'm just going to throw it at the end. Okay, next step, let's add the b over 2 squared. So in this case, take 2 divided by 2 and then square it. That's where we get 1. And then do the same thing with 6 here. Divided by 2 and square it is 9. But notice that we added 1 and 9, which is 10. So you have to take away 10. Okay, let's factor this out. We have x plus 1 quantity squared, y plus 3 quantity squared, minus 4. So you can kind of think of this as a vertex. So x is going to be negative 1, y is going to be negative 3, and then the value, like f of negative 1, negative 3, is going to be negative 4. Okay, so this will be actually a minimum of negative 4. But this is the critical point, which we needed to find. Now let's do it using the partial derivative test. So let's first take the derivative with respect to x. We get 2x plus 2. Let's take the derivative with respect to y. We get 2y plus 6. Now we need to set each of these equal to 0. We get x equals negative 1, y equals negative 3. And notice that's exactly what we got using the previous method. Okay, next problem. Let's use a second derivative test to identify any critical points and determine what each critical point is. The function is x cubed plus y cubed minus 300x minus 75y minus 3. Let's take the partial with respect to x, and then we'll do y. Okay, so for this, set them both equal to 0 to find the critical point. So this we get 3x squared equals 300, x squared equals 100, so x is plus or minus 10. Similarly for y, we have 3y squared equals 75, y squared equals 25, so y is plus or minus 5. So now we can figure out all the combinations of critical points. So shorthand way to write it is plus or minus 10, plus or minus 5. But you want to get all 4 of these. So they can be all positive, all negative, and then each one could be negative. So we found our critical points. Now we want to classify them. And for that, we need to find the second derivatives. Okay, so first, let's find second derivative of x. We get 6x. Second derivative of y, we get 6y. And then partial of x and then y. That's going to be 0. So we get the matrix, the Hessian matrix. So this will be 6x, 0, 0, 6y. So that's going to be, the determinant is 36xy. Okay. So for 10 and 5, plug in x equals 10, y equals 5 for the determinant. And for that, we end up getting 3600, or rather, let's see, 360 times 5 is 1800. So that's positive. Now the second derivative is 6x. So if you plug in x equals 10, you get 60. That's also positive. And we'll classify this in a second, but let's move on to negative 10, negative 5. So when you plug in two negatives, they're going to cancel out and you're still going to get a positive number. Now for the second derivative, 6x is going to be negative 60, and that's negative. So now we do negative 10, 5, and then 10, negative 5. So because one of them is positive, the other one is negative, we know the discriminant is going to be negative. So it's going to be negative 1800 for both. And the second derivative with respect to x here is going to be negative 60, since x is negative 10. And then for this one, it's going to be positive 60. Okay, now let's classify these. Because the discriminant is positive, we can find if it's a max or minimum. Okay, so for the first two, discriminant is positive. And then here, because the second derivative is positive, there's going to be a minimum. And because the second derivative is negative, it's going to be a maximum. Here, the discriminant is negative for both of these. So those are going to be saddle points. So they're going to be neither maxes nor mins. So now we can actually find what the max and the min is. So we would just plug in 10, 5, and then negative 10, negative 5. So 10, 5 was the minimum, and that's going to be negative 1,753. And the maximum is 1,747. Let's find the maximum and minimum using the method of Lagrange multipliers, the given function. The function is x squared plus y squared. The constraint is x minus 1 quantity squared plus 4y squared equals 4. So for this, we want to set the partial derivatives equal to each other. And first, let's find the partial derivatives with respect to x. So that would be 2x. And then take the derivative here with respect to x. Ignore the 4y squared and the 4. We get 2 times x minus 1. And then now take this with respect to y. We get 2y. And then this with respect to y will be 8y. Okay. I'm going to work with the last equation here. So I'm going to bring everything on one side. So let's subtract lambda 8y and factor out a 2y. So we get y is 0, or lambda is 1/4. So we want to use both of these cases. Okay. Now, okay, let's take y equals 0. We would have x minus 1 quantity squared plus 0, which is nothing, equals 4. X minus 1 then will be plus or minus 2, since you'll be taking the square root of 4. And then x will either be negative 1 or 3. So there's two cases here. So you would get negative 1 comma 0 and then 3 comma 0. So that's just using y equals 0, but now we could also use lambda equals 1/4. So for that, we have to look at the other equation. So we would have to look at this first equation. So we have 2x equals 1/4 times 2 times x minus 1. So 2 times 1/4 will be a half. Multiply both sides by 2, you get 4x equals x minus 1. And then you have 3x equals negative 1, so x is negative 1/3. Okay, let's find the y value. For that, we have to plug in negative 1/3 in for x. And then we have 4y squared equals 4. Negative 1/3 minus 1 is negative 4/3. Square that, you get 16 over 9. And now we can subtract both sides by 16 over 9. Divide by 4. And then take the square root. So the square root, we get two answers, plus or minus square root of 5 over 3. Okay, so here the x value we said was negative 1/3, and then the y value is either plus or minus root 5 over 3. So we basically get 4 different answers. Okay, so let me just write these out, and then we have to compare them. So we have negative 1, 0, 3, 0, and then negative 1/3 plus or minus root 5 over 3. Keep in mind, f of xy was x squared plus y squared. Let's plug it in and figure out what happens. So for negative 1, 0, we get 1 if we plug it in here. For f of 3, 0, we get 9. And then for the last one, we don't care if the y value is positive or negative because we're going to be squaring it. So you're going to get the same answer regardless. For that, you get 2/3. Okay, so keep in mind we want a minimum and a maximum. The minimum, the smallest of these is 2/3. So the minimum is at negative 1/3 comma plus or minus root 5 over 3. And the minimum is equal to 2/3. The maximum is at 3 comma 0, and that's going to be 9.